Hello, this is Mr. Rasmussen with Algebra 1, Lesson 93. In this lesson, we're going to be multiplying rational expressions to get a product, and then also dividing rational expressions to get a quotient. And it's quite simplistic in its work. You already know how to factor, and so that's really what it involves, and then some canceling. So let's start out with the example 1 from the book there. You notice that as you start out, it shows you that if you multiply these out, like if you multiply the x squared by these three terms and the negative 7x by these three terms, you get something pretty big and a little bit complicated. And there's actually an easier way, which is what they're showing you as you look down in the next line. To multiply these, the first step we're going to do is factor them into smaller terms. So, as you see here, the x squared minus 25 can actually factor into x minus 5 and x plus 5, so two binomials. On the top here, we can't do that, but we can factor out an x. So if we take an x out, we have an x plus 3 left. On the bottom, once again, we take out an x. When we do that, we're left with x minus 7. And then the last one this trinomial can factor into two binomials. We get x and x here. This is a negative, so one has to be negative, one has to be positive. And then it looks like we're going to get a negative 5 and a positive 3 there to be able to get that to work out. Negative 5 times 3 is negative 15. Negative 5 negative 5 plus 3 is a negative 2, so that works. Okay, so once we factor it that way, then since what's in parentheses is all connected by multiplication, we can cancel what's on the top and the bottom if it's the same thing. So for example, we have an x to the negative 5th here, or negative 5 here, and 1 right here, so those cancel each other out. X minus 5 divided by x minus 5 is 1. We have an x here and an x here, all connected by multiplication on top and bottom, and division there, so those cancel out. And then we have an x plus 3 and an x plus 3. Those cancel each other out. We are left with an answer of x plus 5 over top of x minus 7 as the answer. Okay, as we move on to the second part with division, division is really done the same way with one thing we do at first. Just like in elementary school when you have two fractions and we're dividing, let's say we have 2/5 divided by 3/4. Same as elementary school, what do? Well, you flip the second fraction, right? You invert it and then it becomes multiplication. Same case here. So we're going to keep the first part the same. Not going to change that one, but then we're going to flip this second equation, okay? We're going to, or not equation, rational expression. We're going to flip that one. So this goes on top, and then it's x squared plus 5x goes onto the bottom, and now it is connected by multiplication, and we do it the same way as we do the first one. So let's work through that. This top one here, we can take an x out. We're left with x minus 2. On this one top, we're going to factor that into two binomials. We get x and x, two pluses because this is a plus and that's a plus, and then two numbers that looks like 4 and 3. Over here, we're going to factor this one, x minus plus because that's a negative. The higher number is a positive, so we get that. So it looks like a 2 and a 4 here. And then this one we can just factor out an x, and we're left with x plus 5. All right, now that I did that, I'm looking top and bottom, what will cancel? These two x's will cancel out. I got an x minus 2 and an x minus 2, an x plus a 4 and x plus 4, and I'm left with x plus 3 over top of x plus 5. And there is my answer for example 3. Okay, go ahead and pause the video, work through the practice problems to see if you can get it. And I'm going to work through those now so that you can see the work and check your work. All right, practice problem A. They give you the division 1 first. So our first step is to flip that second expression. So here's my first one. It's going to be connected by multiplication, and I'm just going to simply flip it. Alright, there we go. Okay, let's factor some things here. And this one here is going to get factored in two binomials. Negative and a positive. To get that to be a negative, we've got a negative x there, so it looks like a 3 and a 2. This one here is going to get factored. 40, two numbers with 40, and then when we add them, is going to give us a negative 3. That one is going to be, looks like a negative 8 and a positive 5. Alright, over here, x and x, negative and plus, because that's negative. Alright, 16 looks like a positive 2 and a negative 8 to give us that. Over here, we simply pull out an x, and it looks like that. Alright, my x negative 3, those cancel. X negative 8, those cancel. X plus 2, those cancel. I'm left with x plus 5 on top. And it looks like all that I have left on the bottom is an x. There's my answer for practice problem A. Alright, let's do one more. Practice problem B here. Gonna factor x and x, plus and a plus, two numbers. Let's see here, I got to get a 12 in there. That's a pretty big number. 2 and 18. Nope. 2 and 18 when you... Oh, we're adding the numbers. There we go. I'm thinking subtraction. Okay. 36. That's 6 times 6. There we go. Not too hard. Alright, 6 times 6. And let's factor this one. A negative and a positive there. That's looking like positive 7 and negative 3. Let's factor this one. X and x, plus and plus. Adding these numbers, so it looks like 7 and 6. And one more to do, x and x. This is a negative, so negative here and a positive. My larger number is going to be positive to get me that. And so I think 6 and 4. Alright, there we go. Let's see what cancels. Alright, so remember they have to be one on the top and one on the bottom. So I've got an x plus 6 here and an x plus 6 there. I do have another x plus 6 over there, so those all cancel out. I've got an x plus 7 and x plus 7, and nothing else cancels, so that leaves me with an answer of x minus 3 over x minus 4 as my answer. Okay, once again, if you're stuck, please feel free to contact me, send me a text, and I'll work with you there. Otherwise, have a great day.